So that's the second question. Given that the PDF of the joint random variable x y equals to one divide a multiple or one divide one of a multiple y square multiple x, and when y is more than or equals to one and x is more than one of y less than y. So the first question, draw the non-zero definition region of the PDF of xy. So we can get this definition region on the limits that y is more than or equals to one, and x is more than one of y is less than y. So y is more than or equals to one is just the area that belows this strip y equals to one below no upper this strip, and then x is more than one of y is less than y, just like this two function intersect on x equals to one and y equals to one. So this shaded area is that non-zero definition region of xy. And the second question, find A so that the PDF of xy is a valid joint density function. So if we want to make the fxy a valid joint density function, so we just get the integration of fxy from minus infinite to plus infinite equals to 1. So we just integrate y from 1 to plus infinite, 1 to plus infinite, and integrate the x from given exact y, x is from 1 of y to y. So we just take that integration. After some mathematical method, we just get that a equals to 2. And the third question, find and draw the marginal density function fx and fy. So the marginal CDF of x and y just equals to the CDF joint CDF for x equals to plus infinite or y equals to plus infinite, and the PDF of marginal density function fx and fy just the derivative of marginal CDF. So we can just get the PDF of marginal density function fx equals to the joint PDF of xy integrates the y from minus infinite to plus infinite. It just equals to when x is more than 0 and less than 1, this function equals to integrate the y from 1 of x to plus infinite. So it equals to 1 of 2. And when x is more than 1, the PDF of x, marginal density x, equals to the integrate of y from x to infinite plus infinite is just equals to 1 of 2 multiple x squared. So in the same method, we can just get the marginal density function fy equals to the integrate x from minus infinite to plus infinite, the joint PDF of xy. It equals to integrate the x from 1 of y to y. It just equals to ln y divide y squared when y is more than or equals to 1. So we can also draw the marginal density function of fx and fy. Fx is like this diagram, and fy is like this diagram when y equals to square root of e, it's the maximum of Fy exists. And the last question, verify Fx and Fy are density function. We want to verify it. We just calculate the integration from minus infinite to plus infinite. So the integration of marginal density function Fx just equals to 1 of 2 plus 1 of 2 equals to 1. So as the density function of Fy, the integration of Fy just equals to 1. So we just verify the Fx and Fy are valid density functions according to their integration. So that's all my homework. That's all my homework 5 solutions. Thank you very much.